All right, welcome everyone, and thanks for inviting me to this fantastic event. I appreciate it, and I look forward to hearing some of the questions. I'll preface the entire presentation, obviously, by I'm not an engineer, or computer scientist, or otherwise. I'm a user. I'm an investor. I'm a leader at a container terminal or transportation infrastructure. That's what I've been throughout my entire career, a user, leader, manager. So I'll be talking about this from a use case perspective, what I've seen actually in place, and how I've been thinking about this for the last 30 odd years as terminal operating systems, terminals, and businesses have tried to increase their results every year ad infinitum, and how much blood is there left to squeeze out of that stone. So hopefully everybody can now see my screen and my lovely face still. So when we think about the container terminal operations, and the operators there on the terminal, I've classified them into three major challenges. And the first and foremost is going to be around operational volatility. And that, goes down to the simple things like container attributes that we all know that the TOS deals with quite well: size, weights, contents, conditional circumstances, hazardous, reefers, and then the physical attributes of both the infrastructure, where the reefer plugs, et cetera, and the permanent attributes of the containers themselves, the heights. And then we start to get into the things that are changeable, that are variable. We start to talk around retrieval orders and expected dwell times on import containers, or even intermodal containers or transshipments. Accessibility for the loading and unloading, the different types of equipment that are in the CY complicate this puzzle that we have. Reach stackers, top loaders, RTGs, ASCs, et cetera. Everybody's got its own advantages, disadvantages in the ability to create the access to the container at the right time. But then we have a significant amount of unknowns that we've always had to deal with, more on an intellectual or experiential level. Late vessels, how do the trucks or rail or trains, how do those impact our operation? How can we plan for those? What are the typicals? That of course drives the dwell time from an operational perspective, but then there's further dwell time unknowns around customer requirements, expectations, payment schedules, customs clearance, et cetera. And then there's, in many locations around the world, an entire section of incomplete or missing information on container arrival into the terminal. Sometimes vessels show up with import containers without full information around next destination, or even mode next mode of exiting the terminal. So with all of those operational volatility issues, we then start to run into the problem that, well, most terminal operating systems have been fairly hard-coded logic, if you will, but maybe with multi-criteria for CY container positioning. So penalty points for certain conditions, or certain values in those known or unknown quantities, multiple settings with that are all combined then to create an optimal position in the yard from the TOS perspective. But of course, we can pretty fairly explain and expect what's going to happen when those penalty points are at extreme levels, either very much fit the criteria or very much don't fit the criteria. But what happens when those criteria, when those point settings are sort of in the middle, and what are the unexpected impacts when many of those criteria settings have middling percentages, and then what are the unintended consequences for those multiple settings? And those are difficult to change on a day-to-day basis, setting by setting, circumstance by circumstance. And of course, they apply as we set those. We don't change them as operators every single hour, every single day. And so they're generally applied universally, regardless of the immediate circumstance that we may be facing. So generally, in my view, they're too static. And while they were a fantastic innovation when they were implemented, it quickly became obvious that it was like trying to fly the space shuttle on manual, that there were far too many buttons, far too many settings that could have consequences that we couldn't predict. And then we get to the business aspect, right? So the business aspect is conflicting business goals, right? Well, what does leadership, what does management want? Do we maximize productivity or capacity, right? Who's in charge and making decisions around that? Or are we asking our operators and our in the terminal day to day to take a look at cost per lift only? Is that 90% of what they're being judged by, or is it overall EBITDA? Do they have visibility to that? Is it efficiency versus speed, right? Speed of service versus the moves per man hour. So these are all conflicting goals that may or may not be communicated all the way down, and then drive that behavior at the terminal operator level. So then, why would AI be any better, I guess, is the real question, the next question. And so, generally what we see here too, and that AI has been started to be implemented in the terminal environment fairly successfully in my experience. It can be seamless. So it can be seamless because it can be another layer. It doesn't need to be within the TOS. The TOS doesn't have to be thrown out. It doesn't have to be upgraded. It can be TOS agnostic. So that means that the same AI, same decision-making process can be done regardless of what company you're using as your TOS. And we all know that TOS implementations are extremely complex, extremely time intensive, and extremely costly. So and risky. Let's add that onto that, nonetheless. So we end up with something that's non-intrusive, typically also even nowadays SaaS-based. So we do have some cybersecurity issues, connectivity issues that need to be dealt with, but generally not something else that the terminal needs to maintain or invest in. The digital twins, we talk about that. The digital twins can be set up without impacting the daily operations. We can test and test and test until we get it right separately from the day-to-day business. So it's not about moving those multi-criteria settings along and hoping that the right output comes about. This can all be done offline while the terminal is continuing to do its day-to-day work, and doesn't require a significant amount of terminal assets and involvement in ensuring that digital twin can be set up and that the interface can be aligned well. And then, of course, they're adaptable to any operation. They're able to be used on a manual mode or semi-automated mode or fully automated mode. And AI and machine learning, what they're supposed to do, dynamically adapt to the real-time operational changes and make those decisions on a situational basis for late arriving vessels, late arriving trains, etc. We also get to deploy some pretty cutting-edge technology. So we can start to do what we always wanted to do as terminal operators, and that's take a whole lot of different data sets together and analyze them all at once, right? Your appointments expected, our weather expected, how's that going to impact the traffic outside of the trucks and their arrival for those expected appointments. What is the current yard inventory and projected yard inventory? What are the vessel arrival expectations based on AIS data, not just based on some 8 o'clock report that somebody has given us? Even in some places, trucker app location services to match up with appointments, and of course the rail operations and its train arrival and location information, depending on what part of the world you're in. And the nice thing about it is that we can also then start to mix in others as needed and or as available. So, this is not the end of the data sets that are out there. As things continue to digitize, we'll be able to increase our understanding of the world around us more and more, but only through something like AI or machine learning. And then, of course, we wind up with the ability then to take pattern recognition and take historical information, to try and predict the future. So what was our container pickups on the day after a major holiday with this type of weather, with this type of traffic, et cetera, et cetera? Did we complete as many transactions as we thought we were going to? Did we not? So that we can then start to plan ahead. And that way, then we can start to predict the departure times of the boxes that may be a little bit more unknown, or either through the gate or the rail or the vessel. And we can predict the gate activity, which allows us then to order the right amount of labor, and potentially even, in some places, predict the missing or incomplete information on that we see. If we have a significant amount of missing onward mode forecasts, onward mode information fields, then potentially looking to history will allow us to get it almost right, if you will, on the basis of what we see going into the future. And then we can start to also use KPI alignment. It's not static. We can balance it within ranges. We can align the AI to recognize what it needs to do by customer for service level agreement compliance. We can have it be multi-conditional, so minimum of best fit of lowest cost per lift and speed, or lowest cost per lift and EBITDA, et cetera, et cetera. So we want to maximize production and capacity, efficiency and speed, cost per lift and EBITDA. And that's not an easy thing to balance and calculate out using just the TOS or Excel or our albeit very advanced but limited human brains. So I want to walk you through a couple of experiences that we've had, where we've seen proven benefits to using AI, in particular in the yard, where there's a significant amount of OpEx, lots of yard labor running around, delivering and receiving containers, performing housekeeping, but also CapEx, right? There's huge amounts of dollars invested in yard equipment, whether that be ASCs, RTGs, top handlers, et cetera. First, we'll talk about an RTG facility. So fully manual, fully labor burdened, RTG invested. And this client in particular, is US-based RTG facility. Their objectives, frankly, were to try and reduce the number of container handling equipment resources and reduce the number of rehandles. So they identified a significant way forward with the desire to reduce the unproductive rehandles, but not so much so that it impacted the housekeeping and or the setting up of vessel productivity that they wanted to achieve. So some of those housekeeping moves were maintained because they felt like there was an advantage to speeding up the crane gross moves per hour, but all of the other unpaid rehandles, and even as far as if they could reduce those desired rehandles in the yard, housekeeping in the yard, they would want the AI system to do that. And so what we ended up seeing is a significant reduction in RTG usage per day and a significant reduction in the number of housekeeping moves. A obviously equals B in this case. So, we saw a 23% efficiency gain in reducing those housekeeping moves by predicting the dwell times on the import loads, predicting how the inventory was going to look in the future after vessel arrival times were taken into account, both late and on time, rail operations, et cetera. And all of that then resulted in the ability to not have 3 RTGs deployed on a daily basis if they so chose. So in this case, right, you can do multiple things with those results. So RTG improvements in this case reduced the OpEx, right? Labor, we saved 3 gangs worth of yard RTG staff, energy, so diesel fuel, M&R on all that, and utilization, and of course the CapEx in theory in the future, if we continue on this path, while there's no immediate reduction in CapEx, there is an immediate reduction in the need for replacement CapEx. We would not replace 3 of the RTGs without expecting some sort of growth to pay for those replacement RTGs. Or it allowed them to increase the daily delivery capacity with the same fleet and manning. So in other words, they could offer up more appointments to match the increased capacity that they had just created in the yard, thus increasing the flow if those appointments were the limiting factor. So there's a dual benefit there, but the decision making then is up to leadership on how to take advantage of those benefits. And that decision, by the way, doesn't need to be a forever decision. That's a today we don't need 3 more, and 2 weeks from now, after we've been shut down for a 3-day weekend, we can go ahead and add those 3 back and increase the amount of appointments because there's built up demand. Then we also say, well, but Peter, what about an ASCs, right? They're automated. We don't get rid of the staff to deal with that. We don't get the benefits for it. We can't even get rid of the equipment because the equipment obviously has to be operating in that line and dealing with, even if there's just one container, it needs to operate. And all of that is absolutely true. But what we see is actually fairly similar. But in this case, I'll start from the scratch. Again, another US-based client, their key determination, their key focus was on the gate throughput capabilities. So in this case, where they identified, and we've all faced the automated problem or the problem of semi-automation in the yard, is that those transition points, those transfer points, they are a bottleneck, and the amount of containers that an ASC can handle over an hourly basis is going to limit the amount of deliveries that we can make on either side of the ASC. So they wanted to be able to push more through that landside transfer zone. They thought that by being able to do that would come through eliminating or reducing the number of rehandles for the external truck deliveries and the other overhead moves and rehandles for other housekeeping reasons. So in other words, have every move that landside ASC were to do would be a productive move delivering to a truck. And then that way that they would be able to get more flow through the facility and then therefore keep or improve their yard efficiency at higher occupancy percentages. What they were able to do was significant, and these improvements were actually amazing. And the only time that the manual system, if you will, or the existing automation system was able to beat the AI that was deployed was on the days where they were open on a weekend and there was basically 50 moves all day. So there's obviously no real scale and benefit in that case, but they reduced the moves per delivery, the rehandle moves per delivery by almost half, or by just over half. And then of course the housekeeping cost reduction on an energy and M&R basis was significantly reduced. No labor in this case, but it's all about energy and M&R, and then the amount of throughput able to push through the transfer zones, thus increasing their bottlenecks. So where we also see AI delivering value is in a few other use cases. I've talked about the yard, so we won't need to talk about the resource management much anymore, and even to an extent, the operational gate aspects, managing terminal throughput. But this idea of maximizing equipment availability is another great application, trying to predict not just through use of sensors, but actually through activity-based existing sensors and activity-based data, and going back to historical, on equipment and predicting the failures and anomalies to reduce those operational stoppages, right? And to reduce the corrective maintenance levels. Because we all know that having inevitably as a container operator, it's always the last 5 boxes that somehow end up getting stuck, and the entire ship is now waiting for those containers to get over, but they're stuck on truck, ASC, RTG, et cetera. So making sure that we don't wind up in those situations is key. And it's not just about the time stoppage, it's about the entire impact to the operation, the wrench time of the mechanics, and of course, the amount of capex that we also increase by having a higher percentage of expected utilized che or horizontal transport because of the unknown. So we may know we want 10% unavailable due to preventive maintenance, but then how much do we have due to corrective maintenance? And those are estimates. And the more we can reduce that estimate to zero, the less capex we spend annually. And then, of course, we end up using this data to drive continuous improvement, right? We can monitor and scale the KPIs in ranges. We can identify the constraints. We can also then ensure that we're making the best use of the assets and the space by really tackling the problems in a data-based fashion. So, which is, of course, what we're all trying to do today, but AI allows us to sort through some of the noise, deal with the issues of the unknown all by itself, and then allow us to really focus on the policy changes that we can work with external influences and labor to really foster that efficiency rather than using the spaghetti method, as it might be called, which is throwing it against the wall to see what sticks. So I just wanted to walk through those all with you. That's essentially the end of my presentation. I hope it was helpful. We see a lot more benefit for AI now and in the future. The experience that we've had in deploying and working with terminals on deploying machine learning and AI have been incredibly successful. We're past the point now where AI and machine learning for container terminals is slideware. It's real activity, delivering real value, and those terminals are quickly signing up for this type of investment. And frankly, the level of investment due to the SaaS structure and in places where connectivity is still very good is fairly low for the return on investment. So I hope that was helpful. I don't know, Lawrence, if you've got an idea, questions now or questions later, I'll leave it to all of you.
We'll take questions now, especially since this is online. I see a interesting question from Martin Viting. He's asking, can any specifics of the AI methods being used in the reference projects be shared?
That's a great question. And look, feel free, send me an email if that's interesting to you. As I started off the conversation, I am not a computer scientist. I am not a machine learning expert. So the short answer is yes. I just won't be the one who's sharing it with you. I will be happy to connect you with the right person, and you will be able to investigate that very deeply.
I was going to ask a question. In working in AI and research for 27 years, I'm just interested as why now you think AI is being embraced, because AI itself has been around for over 60 years, actually. Over 60 years, we've had elements of AI. Machine learning was developed in the 70s, deep learning, 80s, 90s. Multi-agents, an area that I've worked in, was developed by DARPA in the mid-90s. So I think it's interesting that in the last 2-3 years, there's just been an overwhelming interest in AI. And what do you think is fueling this?
Well, I think that's a great question. Without getting and being able to go into any of the technical stuff that you described, Lawrence, I think you're right. I think first off and foremost, we are a niche
Mm,
industry, so generally there's not a lot of attention paid to us. I mean, there's some terminals that are still using things like chalk and magnets to mark containers and to track them in the yard. So, we always have a foot in the last century, whatever century we talk about. So, progress is steady, but not very fast.
mm,
That's first and foremost. I think then, there's been an awful lot of focus on upgrading and improving, tosses in particular. And tosses have not embraced this machine learning and AI as much as I would have expected them to over the years, maybe because there was so much other low-hanging fruit on just standard algorithms and
mm.
multi-criteria, penalty points, and so on and so forth, that could be the part of the reason. And then the next bit, I think, frankly, has to do with, over the we'll get up to maybe the last 10 or 15 years, and that's internet connectivity and speeds and
Mm,
and in return on investment for, the ability to get out of on-prem investments for this type of solution and have a whole lot more to maintain, invest in, et cetera. Terminal operators like me, whenever we get the request to add, 5 more servers, because it's never one server. It's always a server and a backup server and a virtual server and there's so much more investment required. And of course, that requires the CapEx has to be maintained and replaced every 5 years or less, depending on the age.
mhm.
And then there's the software, not just the software for the AI, but the Oracle software or the whatever other is in the background. It becomes very complex, and I don't want to say scary, but almost a point where we get out of depth.
Mm,
So I think the advancement and the ability to get to SaaS has certainly helped. The increased attention on supply chain over the last 3-4 years. I mean, the AI that we've successfully seen put in is it's probably about almost 4 years old. So I mean, it's constantly being upgraded, but I mean, it's 4 years ago before the current rush to AI, which is, since ChatGPT hit the streets. That's when everybody, if you
mm,
were a CEO that didn't have AI on your strategic scorecard, you were being questioned by your board heavily. So
mm.
I think we're getting to a point where it's becoming, more of a reality than how, from 2001, forgive the very old reference. But I think it's progressive comfort, frankly, and technology, but not AI technology supporting technology.
Okay. We have one last question from Eduardo Serriera. And his question for you, Peter, is for what terminal size is it recommended to start exploring into AI, mainly due to the cost attached to it?
Well, of course, cost is always a driving factor. So, but I would argue a couple of things, and it's not always the answer isn't always size. It could be solution based. So, if you remember back what I started the conversation about, sometimes the bottleneck that you remove actually improves your throughput. So if you're throughput constrained, your top line is the one that's suffering. So you can never save costs down to zero. That doesn't happen, but you can increase your revenues significantly. So if we go back to this slide, or even to this slide, so either one, and we said that this terminal was gate capacity constrained, and so they were unable to deliver this amount of imports per day, and we were able to do that. Uh, I mean, that's 50 more boxes per day at a top line number. And so the revenue generation possible would far likely, even on a small terminal, pay for an AI module in the yard. If we're talking about savings, I think, then you get into a far more of an ROI conversation. And, I've seen benefits with as low as 150,000 moves. But again, it also depends significantly on the amount of waste. If you happen to have a perfectly laid out yard and you had zero rehandles, well, then clearly this is not going to benefit you in the yard. However, on your equipment side, if you had massive amounts of corrective time and you had double the fleet required because your equipment was always broken, then the return on investment might be on that module. So I think, I hate to wimp out and say, the answer is it depends. But as I said, the nice thing about these deployments is that they're fairly inexpensive, quote unquote. I won't say they're cheap, but compared to the benefits, compared to a TOS module deployment, compared to any other IT system where you need to invest in expertise, servers, maintenance, OpEx maintenance, CapEx, license renewals, it's far simpler, far less risky, and frankly, generally far cheaper.
Okay. I think I see one last question from Ramu. I'm going to see if we can squeeze this in within the time limit. His question is specifically, any indicative numbers on initial investment and return on the investment?
So I can say return on investment percentages. I have seen at least 3 terminals where this was deployed in the yard and it paid back within 6 months of deployment. So, I consider that a fantastic return. And by the way, it's easily seen, right? These are numbers that are very easily measurable, very easily discussed between the deployment vendor and the terminal. There's a list of, expected criteria going in right away. As I said, because AI is a focus on delivering results, that the machine learning and AI deployments are typically, I want to achieve X and Y, so help me do that. As opposed to TOS modules, which focus on overall process and overall benefits. But, TOS providers never guarantee specific numbers, right? And in fairness, they can't, because there's so many unknowns and so many things outside their control. So that's not their business. So I think, we have to look at AI and machine learning as different than a TOS module implementation. There are a couple of models now out there for the AI and machine learning deployments on a SaaS basis. It can be a fixed license, annual license. It can be a fixed and variable component. It can be, fully variable. It depends on what the benefit is that the terminal is trying to achieve. There is always a balance of risk reward also for the vendor to provide. So in other words, a vendor may very well do a fully variable component, but if they have a significant risk in you not achieving the amount of volume through the facility, then that variable component on a per unit basis may be significantly higher than a fixed and a variable or a fully fixed. So those are conversations to have with your deployment specialist, and I'm happy to help you think those through and talk to them about that, how that might benefit you and them.